everyone, good evening and welcome to India's first animated live tuition. Hello everyone, good evening and welcome to another marvelous, beautiful session of chemistry. Are you ready for the session? Are you ready for the session? Give me a double thumbs up if you're ready for the class. Yes, let me know if you are ready with your books, pen, highlighter and everything. Yes, everyone is giving me the beautiful thumbs ups. They are all ready, right? Yes, but still I can see so many camera off there, right? Don't make me to repeat everything in every class. Just turn it on. It's your responsibility, right? You have to turn it on before the class. If you enter the class, you have to turn on the camera. It's a compulsory thing. You know that I'm still doing the same thing in every sessions. Yes, quickly turn it on. Quick. Let it be quick. Yes, do we have any new students in our class? You can just raise your hand, okay? Do we have any new students? Do we have any new students in our class? No new students. All are familiar with the class and me, right? Yes, so here we go with the chapter Chemical Reactions and Equations. And for your kind knowledge, this is our YouTube live. You can share the link with your friends and your circle so that let them get an idea that we are going a YouTube live over there and let them study too. So you can share the link with your friends. Okay. Yes, that's it. So let's begin the session, Chemical Reactions and Equation, which is the first chapter. And in this session, we are going to learn, what are we going to learn? Have any idea about that? I have already mentioned that in the previous session, which is the topic that we are going to cover today. Have any idea about that? You can just comment it. No highlighter, ma'am. That's okay. That's okay. If you don't have a highlighter with you, that's perfectly fine. Combination reaction and that's it. Types of chemical reactions. Very good. The types of chemical reaction. So if you have just opened the textbook, you will get an idea how many types of chemical reactions do we have. Can anyone tell me how many types of chemical reactions do we have to study? What are the types of chemical reaction? And just tell me how many are there. 4, 5, then 3, 2, 1. They're all giving all the numbers.
Decomposition reaction.
Decomposition reaction, definitely 6, 4. So here we go. We have 5 types of chemical reaction, okay? According or based on the chemical reaction which is taking place over there, we have 5 types of chemical reaction, but the first one is combination reaction, the second one decomposition, and the third one exothermic and endothermic reaction, the fourth one displacement reaction, and the fifth one oxidation and reduction reaction. These are the 5 types of chemical reactions that we have to study in this particular chapter. So if you want to study the chemical reactions, you must have an idea about what kind of reaction is that. So you have to study these 5 first. Are you all ready for that? Yes, everyone is busy writing down, right?
Yeah.
Yes, everyone is busy writing it down. I will on my camera in 1 minute. Okay, I'll give you 1 minute.
Yeah, once you're done, give your teacher a thumbs up.
Yes, you can indicate with me by giving me a thumbs up so that we'll move forward. Yes.
Sorry, ma'am, Rihanna said that there are more than one chemical reaction.
More than one. Clever. Rihanna is very clever. There are more than one chemical reaction. Definitely.
He played safely.
Safe play.
Yeah.
Yeah, very good. Here we go. The 5 chemical reaction, and the first chemical reaction that we are going to study is the third one, exothermic and endothermic reaction. For a change, let's study the third one first, okay? Exothermic and endothermic reaction. So in order to study all these things, first we have to know what is exothermic and what is endothermic reaction. So first let's go for exothermic and endothermic reaction. Then we will follow the rest of the things, okay? So the first thing that we are going to learn is exothermic and endothermic reaction. So before that, how many of you know about exothermic and endothermic reaction? You can just raise a hand if you know what is exothermic and endothermic reaction. I'm not going to ask the questions, no worries, just let me know how many of you know what is exactly the exothermic and endothermic reaction.
Ma'am, many of them know it. Thanks.
Many of them knows it, right?
Yeah.
Definitely, it's the basic thing. Everyone must know it. Now let's unmute one.
Okay.
I have told you I will not ask questions, but I'll break my word. I'll ask questions definitely. Yes. Pick someone from the hand raise.
Let's ask Sridhya.
Sridhya. Sridhya, how are you doing, Sridhya? Fine. So you raised your hand since you know what is exothermic and endothermic reaction, isn't it? Now can you tell me what is exothermic reaction?
Exothermic reaction in which heat is released along with the product is called exothermic.
Definitely. Very good. Very good. Now let's unmute one more.
Okay, ma'am. Yeah.
Anyone?
Linda.
Linda. Yes, Linda. What is endothermic reaction? Sridhar explained what is exothermic. So now what is endothermic reaction?
It's the reaction which takes in heat.
In the presence of heat, right?
Yeah.
So that is endothermic, which is the basic thing that we are going to study first. So the first chemical reaction is nothing but the endothermic and exothermic reaction. Endothermic and exothermic reaction. As the image itself says that the first one is endothermic, by the absorption of heat. The chemical reaction takes place by the absorption of heat from the surrounding or from any other source is known as endothermic reaction. And during a chemical reaction, if heat is liberated to the surrounding, we can call that as exothermic reaction. So endothermic is heat or the energy is entering. Enter, endothermic. Exiting, exothermic. You can remember like that, okay? Endothermic, heat is entering. So exothermic, heat is exiting. So like that you have to remember. You don't get confused with the endothermic and exothermic. Never ever get confused with the endothermic and exothermic. Okay, which is a very important kind of reactions. So what is endothermic? Okay, so what is endothermic? The reaction takes place by the absorption of heat energy. It takes place by the absorption of energy is called as the endothermic reaction. Here we have melting of ice. Melting of ice. They takes the energy or they takes the heat from the surrounding and they melt down. Right? Am I right? In order to melt an ice, they have to get the heat energy, right? They absorb the heat energy and they melt. So melting of ice is an example for endothermic reaction. What is endothermic? They absorb the heat energy to take place a chemical reaction. A particular chemical reaction is taking place by the absorption of heat energy, which is nothing but endothermic reaction. Now what is exothermic reaction? What is exothermic? The heat is liberated during the chemical reaction. During a chemical reaction, heat is just liberating. So burning. If we burn a wood, we will feel that heat from the surrounding, right? We can feel that heat. They are liberating the heat. They are exiting the heat. Exothermic. So we have two types of chemical reaction based on the absorption and liberation of energy. So based on the absorption and liberation of energy, we have two types of chemical reaction, endothermic reaction and exothermic reaction. Exothermic and endothermic reaction. Is this too clear for everyone? Is this too clear for everyone? Any doubts, anyone? No. If you have any doubts, you can ask in the comment box, okay? We have a supporting tutor over here and she will support you with that, okay? So here we go, the two chemical reaction, endothermic and exothermic. So can you give the example, daily life example for endothermic and exothermic reaction? Can you give me some examples? Can you give me some example for daily life, endothermic and exothermic reaction? We have a lot, right?
Shall we ask some of them?
Yes, we can.
Yeah. Okay. Fatima.
Fatima. Fatima.
Hi.
Hello, Fatima. Can you give some examples for endothermic and exothermic reaction?
Please sweating,
It's not audible. It's not clear.
fighting,
Fighting? Fighting with your siblings or
no
friends?
sweating,
Sweating! Haha, definitely.
no sweat,
Yes, sweating. I thought you're fighting with someone, and fighting is an endothermic process. Yeah. During fighting, we all getting hot, right? Yeah. Example for the exothermic reaction. Fighting is an example for exothermic reaction, definitely. Yes. Very good, very good. So here we go. Let's have some examples, okay? Daily life examples. So the first one. Where is it? Wait a second. So first learn what is exothermic, okay? Who's that?
It's okay.
It's okay. Someone called me from nowhere, and that's okay. Alright, so exothermic reaction. What is exothermic reaction? The reaction which is accompanied by the evolution or the liberation of heat is called as the exothermic reaction. As you can see in the image, the heat is liberating, right? The heat is liberating, so it is an exothermic, exothermic reaction. So a reaction which is accompanied by the liberation or the evolution of heat energy or just the energy is called as the exothermic reaction. Exothermic reaction. Quickly write it down. Ma'am, I don't have this in my textbook. Can you explain this briefly? This first time I'm learning this. Your first time learning the exothermic and endothermic reaction. I'm just explaining it, okay? I just begin the class, so no worries. Here we go. Exothermic. So what is exothermic? The reaction which is accompanied by the liberation or evolution of heat energy is called as the exothermic reaction. So based on the evolution or the absorption of heat or the energy, we have two type of chemical reactions. Exothermic reaction and endothermic reaction. So here we go with the first one, exothermic reaction, and let's check out some example for the exothermic reaction, okay? Who was that? Zaid.
Yes.
Zaid, was that clear? The exothermic? Zaid, is the exothermic reaction clear for you?
Yeah.
Yes, definitely. Here we go with some examples of exothermic reactions. First one, respiration. Respiration, can you believe during respiration it is a exothermic reaction. It's an exothermic reaction. Can you feel the heat energy that is liberating from your body? Do you have a feel like that you are liberating the heat energy to the surrounding? Do anyone have felt that? Or is it like, ma'am, how can respiration be an exothermic reaction? Ma'am, could you please show the previous slide? Yes. Here we go. So what about respiration? Is it an exothermic reaction? How respiration becomes an exothermic reaction? Can anyone explain to me? Can anyone explain to me? You can just raise your hand if you know the answer. How come a respiration becomes an exothermic process? No worries. I'll explain it, okay? So are you done with the slide? Are you done with the slide? Shall I move forward? Shall I move forward? Definitely. So here we go, the respiration. So respiration is an exothermic process. So everyone listen to me carefully. I want your 100% attention. I want your 100% attention. So pay attention to my class. Otherwise you will not get any idea about the reaction. So we have plenty of chemical reactions. If you don't pay attention, you will get confused because we have a lot of chemical reactions coming by. So pay attention during the class. Respiration. Respiration is a kind of burning fuel, right? It's a kind of burning fuel. We always intake what? We always intake the foods, right? And the foods will be having what? Carbohydrates in it. Food will be having carbohydrates in it. Food will be having carbohydrates in it. So during the respiration or the digestion is also an exothermic process. Okay. So during digestion, the carbohydrate will break down into simpler glucose units. Carbohydrates will break down into glucose. Carbohydrates. So our food will break down. Okay. Food will be having what? Food will be having carbohydrates in it. Food will be having carbohydrates in it. So during the digestion or respiration, this carbohydrates will break down into simpler units called as glucose. So it will break down into glucose units. And these glucose will combine with oxygen. Will combine with what? Will combine with oxygen. We respire, right? We intake oxygen which will be present in the cells. So the glucose will combine with the oxygen that is present in the cells of our body. And as a result of this, they will liberate the heat energy. Which will be utilized by our human body. So what is happening over there? Food will be having carbohydrates in it, which will break down during the digestion. And it will break down into glucose, and this glucose will combine with oxygen. During this process, they liberate the heat energy. Liberation or evolution of heat energy is exactly called as what? Exothermic process. So respiration exactly is a exothermic process. Okay. Never ever get confused with that. Respiration is a exothermic process. Never tell like exothermic is an endothermic process. If you tell like that, I will come there and will beat you. Okay. So respiration is an exothermic process where the liberate or evolution of heat energy takes place over there. Okay. Exothermic process. Was that clear? Shall I move forward? Give me thumbs up. Very good. Here we go with the next one. What is this? Can anyone tell me what kind of process over here? What is taking place over here?
Comment below.
You can comment it.
Ma'am, anyone in India is saying it's a decomposition.
Definitely, it is compost. Right? The breaking down of vegetable matter into compost is called as what? Is called as again an exothermic process. So the decomposition or breaking down, cutting of veggies.
Yeah.
Why they are cutting veggies inside these rubbish things? So they are decomposing or they are throwing off the veggies, okay? Alright. So they are converting them into compost. So breaking down of vegetables into compost. So what is this? A breaking down or the decomposition of vegetable matter into compost is an example for exothermic reaction. So during this breakdown, the heat energy will be liberated. During the decomposition or during the breakdown of this vegetable matter, what happens? The heat energy liberates. So we can exactly call this as what? An exothermic process. Okay, is it clear? The second example clear for you? The first one is respiration. The second one, breaking down of vegetable matter into compost, is an example for the exothermic reactions. So I hope everything is clear. Let's unmute one man.
Sure. Okay.
Yes.
Amna Fatima.
Amna. Is everything clear?
Yes, ma'am.
Yes, very good. Now let's move forward, okay? We have so many more examples. So water. when water mixed with acid or acid mixed with water, during those chemical reactions, a large amount of heat energy will be liberated. So water with acid is an exothermic process. It's an exothermic process. What is it, ma'am?
How is heat energy produced?
By breaking down the materials, the heat energy will be produced.
Honey, I think you have got the answer.
Okay.
Okay.
Yes, water and acid react together. Okay, so water and acid react together. The chemical reaction will be accompanied by the liberation of heat energy. So water and acid reaction is an example for the exothermic reaction. And as you can see, campfire. During the burning of this wood, a large amount of heat energy will be liberated. During the campfire, we get that hotness by burning the wood, right? So campfire is an example for exothermic reaction. And rusting of iron again example for the exothermic reaction, where it is a slow process. Okay, it's a slow process, but the heat energy will be liberated during that chemical reaction. So rusting of iron again an example for the exothermic process. And nuclear fission and also nuclear fusion, both of them are example for the exothermic reaction, where the heat energy will be liberated. Large explosions, bomb, a large amount of heat energy is liberating, right? So it's an example for the exothermic reaction. And freezing of water into ice, they are also exothermic process. They are all exothermic process. Okay, so water into ice, they have to liberate the energy, right? So they have to decrease the temperature, then only they can become the ice, right? Water will be having more temperature than the ice, so they have to liberate the energy in order to become an ice. So they are liberating the heat energy during that chemical reaction. So it's not a chemical reaction, it's a physical change, and during that physical change too, the heat energy is liberating. So again, an example for the exothermic reaction. Okay, clear? Shall I move forward? Yes, very good. Here we go with the examples. Okay, these are the important things. You don't have to remember any of that thing that we have discussed. You don't have to remember that. But the thing that you have to remember is these chemical reactions. Okay, you don't have to remember what is respiration, what is digestion, what is composting. You don't have to remember all those things. But all the thing that you have to remember is like these chemical reactions and equations. So here we go. Burning of natural gas is the first example that you can give for exothermic reaction. So from the beginning also, I'm telling you like you have to write down everything and you have to keep on practicing with these chemical equations and the reactions. I have told you we have a lot of chemical reactions coming by. In all the chapters we have lot of chemical reactions like this. So you will get confused for 100%. So all you have to do is what? You have to keep on practicing everything. Day by day. Okay? Don't ever forget that. So the first one, burning of natural gas. Burning of natural gas is the first example that you can give for exothermic reaction. So what is natural gas or CH4? What is CH4 called as? What is the name of CH4? Comment it. What is CH4?
Ma'am,
We have the answer and unmute one. Yes.
okay, we'll ask Safura.
Yes, Safura. So what is CH4? What's the common name that you can give for CH4? Safura, can you please unmute?
Yes.
What is CH4?
Can you repeat?
What is CH4? What is the name that you can give for CH4?
Methane.
It is methane. Very good. It is methane. What is O2?
We'll ask Radia.
Oxygen.
She already gave the answer.
Okay.
Yes. And what is radio?
Yeah.
Radio, what is
Yeah.
CO2?
It's It's Radhya. Okay.
Okay, right.
Siatia. Alright, yeah, sorry.
Okay.
Alright.
So,
What is CO2?
CO2 is carbon dioxide.
And H2O is?
It's water.
It is water. Very good. Very good. So here we have a chemical reaction where methane, okay, during burning, they react with the oxygen that is present in the air and they produce carbon dioxide, water with the liberation of heat energy. If they are liberating the heat energy, I can call this reaction as what? Unmute one, ma'am.
Sure.
What can I call this chemical reaction as if they are liberating the heat?
Leora.
Leora.
Exothermic.
It is
reaction.
exothermic. Very good. It is an exothermic reaction. It is an exothermic reaction. Very good. So what is exothermic reaction? They are liberating the heat energy. So methane reacts with the oxygen. So whenever the carbon substance react with the oxygen, whenever a carbon substance, remember this, whenever a carbon substance react with oxygen, they will produce carbon dioxide, water and heat. Never ever confuse with that, and I can call these chemical reaction as what? Except exothermic reaction, I can call another name for this chemical reaction. What is that? What is that?
Fissa.
Fissa, yes, fissa. If carbon is reacting with the oxygen that is present in the air to produce carbon dioxide, water and heat. What is this reaction called as?
Combination reaction.
Combination. No.
No, it is not a combination reaction. I will explain what is a combination reaction, but it's not a combination reaction. But it starts with a C. Starts with a C. Anyone have any idea? You have studied that in the 8th standard, right? How can you forget that? You are already in a 10th grade and forgetted everything that we have studied in the previous classes. How can you forget that? It's a continuation, right? So you have to remember everything. Right? No worries. If you don't remember to, we are here for you, right? So this chemical reaction is known as combustion reaction. Remember the combustion?
Combustion. Yes.
Yes. For the exam, you have to mention the states of the substances. You have to mention it, definitely. It is called as combustion. Combustion. How can you forget the combustion, students? Never ever forget the combustion, okay? What is combustion? When a substance reacts with the oxygen that is present in the air to produce carbon dioxide and heat is called as a combustion reaction. So if any carbon substance react with the oxygen, they will produce carbon dioxide, water and heat energy. Okay. Ma'am, instead of heat, we can put a triangle symbol above. No, the heat energy is liberating over here. If you put a delta or the symbol over here, that means they are absorbing the heat energy and you are representing an endothermic reaction, not an exothermic reaction. So never ever put this thing over the arrow mark for the exothermic reaction, okay? It is for endothermic, not for exothermic. So if you put over there, it means they are absorbing the heat energy. So never do that. It's wrong. So heat energy should be written over here. Okay. It's a product. So heat energy should be written over here for exothermic reaction. Alright, so it's a combustion reaction. Carbon dioxide, water and heat energy will be liberated. If heat energy is liberating, I can call that as the exothermic reaction. And again, I can give one more example. Let me rub it. Okay, I hope everyone is taking down everything. Am I right? There is a combustion. Taking down, right? You have to take down everything. These things are not there in your textbook. So please write it down. Ma'am, in the textbook it is written as H2 as gas, not liquid. So it's gas. The water can be liberated as the gas. Okay, water vapor. So it can be either represented as the G or L. No matter. No worries. So here we go with the second one. Burning of magnesium ribbon. Burning of magnesium ribbon. We are all familiar with the burning of magnesium ribbon, right? Burning of magnesium ribbon, again an example for what? Again an example for exothermic reaction, and also it is an example for what? It's also an example for the combustion reaction. Combustion reaction where the light also will be formed. Light energy will be formed. Okay. Heat also will be formed. Light energy will be also formed. And this chemical reaction is again a combustion reaction where a substance react with oxygen that is present in the air to produce heat. Okay. Alright. So they are producing the heat, so I can call this as the exothermic reaction. Exothermic reaction. So here we have magnesium reacting with the oxygen to form what? Unmute one, ma'am.
Nandana, Biju.
Nandana, what is this product called as? Magnesium reacts with the oxygen to give what? Nandana? What is MgO? Quick, we don't have time.
Nandana.
How come the time flies? Quick.
Nandana, you're not audible. Can you please?
Nandana, you're not audible for us. What is MgO? You can comment it.
Okay, then we'll ask Muhammad
Ishan, how is light also formed? I'll show that, okay?
Ma'am, the MgO, magnesium oxide.
Very good, it is magnesium oxide. Very good. It is nothing but magnesium oxide. Magnesium reacts with oxygen to give magnesium oxide and heat. If heat energy is liberating, I can call that as an exothermic reaction. So the animation for us. Yes, let's check it out. So someone asked like how does this light is formed? So they will give a white flame. Okay, they will give a white flame. Yes, sir, the animation. Let's take out with an animation. Okay, let's take out. We have the table, and can you see the magnesium ribbon over there? Can you see the magnesium ribbon? And you can see a white coating on the magnesium ribbon, right? We can see a white coating over there. Can you share the definition of what?
Combustion.
Yes, sir. Yes, sir. So here we have the magnesium ribbon. Magnesium ribbon is filled or covered with a white layer, and that white layer is known as the magnesium oxide. We have to rub it off before burning it. Okay, before burning it, we have to just rub the surface of that magnesium ribbon in order to remove that. So if we rub that, we'll get a clear surface. Okay, before that we had magnesium oxide over there. Can you see the magnesium oxide was there? By reacting with the air, they forms a layer of magnesium oxide. So in order to remove that magnesium oxide layer, we have to just rub it. And let's take that cleaned magnesium ribbon and let's burn it. Okay, let's burn it. And you can see the white flames coming out, right? By the liberation of heat energy and light, we can see the formation of magnesium oxide over there. So what is magnesium oxide? Magnesium reacts with oxygen that is present in the air to produce the magnesium oxide. During this chemical reaction, heat energy also produced. So white flame will be also produced. So this is an example for the exothermic reaction. We have the hand raise over there. Any doubt? Ma'am, hand raise over there.
It's okay.
Yeah, you will manage it. Alright.
Actually, Joanne wants to know the definition of combustion that you have told.
Yeah, combustion is nothing but a substance reacts with oxygen that is present in the air to produce heat and light. Okay, it's called as the combustion reaction. You have already studied that in the lower classes, right? The basic thing. Yes. So here we go with the next one. Okay, you have learned about the exothermic reaction. Now we have to learn what is endothermic reaction. Endothermic reaction. So what is endothermic reaction? Reaction which occur by the absorption of heat energy is called as the endothermic reaction. You can see that, right? While cooking an egg, while making the omelette or half-boiled egg, we always use the burner, right? We always provide the heat energy. So by absorbing the heat energy, the food cooks. So cooking of food is an example for endothermic reaction where they absorb the heat energy. So the reaction occur by the absorption of heat or energy in the form of light, electricity or heat is called as the endothermic reaction. So energy might be in the form of light, electricity or heat. It might be anything, okay? So endothermic, absorption of energy. It might be heat, electricity or light. It might be anything, okay? So here we go. The cooking is an example for endothermic reaction. Okay? Here we go with the next one. The photosynthesis. Photosynthesis is exactly again an example for endothermic reaction where they absorb the light energy. Can you see? They absorb the light energy for the photosynthesis. They are absorbing the energy for the photosynthesis. So photosynthesis again an example for endothermic process. Never ever forget it, okay? So what is endothermic? They absorb the energy. Why are they absorbing energy? In order to take place a chemical reaction. So photosynthesis is taken place by absorbing the light energy from the sun. So again an example for endothermic reaction. So what we have to do? We have to study the chemical reactions. So let's go for the examples. Okay? Light is produced by fire. Definitely light will be produced, right? If you are in a dark place and if you're firing a candle or any matchstick, you will get a light spread over there, right? Yes, light will be produced. Yes, and here we go with the examples, okay? What is HGO? Do you know what is HGO? Baking, can it be endothermic reaction? Yes, baking is an example for endothermic reaction. They are absorbing the heat energy to bake, right? So example for endothermic. Yes. What is HGO? Ma'am, unmute one.
Okay,
Evelyn, what is HGO? Evelyn?
Mercury
Yes. It is mercuric oxide. Very good. It is mercuric oxide. HGO is mercuric oxide. And this mercuric oxide is absorbing the heat energy. So we have to put heat energy in the reactant side, not in the product side. In the reactant side. If heat is there in the reactant side, you must know this is an endothermic reaction. So they will give an equation like this and they will ask which is the chemical reaction taking place over there. Is it an exothermic reaction or an endothermic reaction? So you have to clearly watch or see the equation and you have to write it down, okay? So if heat is there in the reactant side, it is an endothermic process. It refers that the heat energy is absorbed. If heat energy is given in the product side, you have to mention that as an exothermic. They are liberating the heat energy. So heat energy is there in the reactant side over here. So it is an endothermic reaction. What is HGO? Mercuric oxide is HGO. Hg is mercury, right? Hg is mercury, so HGO is mercuric oxide. Absorb the heat energy to form mercury and oxygen. Mercury and oxygen. As we know, mercury is a liquid, right? Mercury is in liquid state, which is the only one metal which is present in the liquid state at room temperature. Only one metal which is present in the liquid state at room temperature. That's the general knowledge, we all know that. So they form mercury and oxygen, thereby absorbing the heat energy. Either you can put a plus sign with a heat, or either you can also write it like 2HgO heat or delta over here. Okay, what kind of delta is that? Let me write it properly. So here we go with the delta and 2Hg plus O2. Either you can write like this, or also you can write it like HgO heat then 2Hg plus O2. It's your wish. It's your wish. You have 3 ways. It's your wish how to write it. Okay, 3 of them are very much correct. Ma'am, would you? Yes, I will show that. Region. I can show that animation. You want the animation, right, Region? Or the equation? Do you want the equation or the animation, Region? You can comment it, okay?
Equation.
Equation. Yes, equation. So, I'll give that by now itself. 2mgO gives 2mg plus O2. Here's the equation, okay? Here's the equation. And MgO is a solid, Mg again is a solid, O2 is a gas. Example for what? Example for heat. Oh, okay. You want the reverse one, right? I'm sorry. That's the formation of this. Here's the equation, okay, Rujan? This is the equation. That's an example for the exothermic reaction. And here we go with the endothermic reaction. So I will give you a few more examples for that, okay? 2 more examples. Let me erase it first. And here we go with the next one, okay? What is NH4Cl? NH4Cl. What is NH4Cl? It is ammonium chloride, right? It is ammonium. Someone is like watching movie over there. Are you writing down everything? Can everyone show me a notebook? Let me check that. Can everyone show me a notebook? Let me check. Very good, very good. Keep doing that, okay? So, David, where's your notebook? David, where's your notebook, David? Unmute him, ma'am.
Sure.
Ma'am, I don't have a notebook.
You don't have a notebook. Why? Why don't you have a notebook? Is this your first class? David? David, is this your first class? David, unmute. Is this your first class, David?
No, ma'am.
No. Then how can you sit here without a notebook?
I just don't have a notebook with me right now.
Are you watching movie over here or studying?
No.
So can you tell me what kind of reaction is this?
It's exothermic.
It's an exothermic reaction. Very good. It's an exothermic reaction. How can you be so irresponsible in my class, David? I have clearly mentioned that you should have a separate notebook for chemistry and for all the subjects. And you're like, I don't have a notebook with me. How's that possible, David? And you're not writing down everything. I have told you we have a lot of chemical reaction coming by, and you will not get any idea what kind of chemical reaction is that. So I have told you have to pay 100% attention in my class. Haven't I? David?
Yes.
So quickly grab your notebook and come back.
Yes.
Yes. Students, we have a lot of chemical reactions coming by, and you will not get any idea what kind of reaction is that, okay? So please and kindly write down everything. And these reactions are not there in your textbook, okay? So here, ammonium chloride. Ammonium chloride absorb the heat energy. Absorb the heat energy. If they are absorbing the heat energy, it's an example for endothermic reaction, not an exothermic reaction, David. It's an the endothermic reaction. They are absorbing the heat energy. and they forms ammonia and hydrochloric acid. Ammonia and hydrochloric acid. Ammonium chloride reacts in the presence of heat energy to produce ammonia and hydrochloric acid. Okay, hydrochloric acid. Ammonia and hydrochloric acid will be produced. Okay, have to keep this in mind. Done? Alright. NH4Cl, heat and hydrochloric acid, they are absorbing the heat energy, so they are endothermic reaction. I'm moving forward, we are out of time. Okay, we are out of time. I've explained everything. So we have the hand raise over there, ma'am.
Yeah. Join.
Yes. Yes, John.
Yeah, ma'am, so when the formula comes, we can write ammonium chloride absorbs heat energy instead of ammonium chloride reacting with heat energy, right? Both the same.
Both of them are same.
Okay, just have confusion. Thank you.
Yes. HCl is hydrochloric acid. Yes. HCl is hydrochloric acid. Now, hope everything is clear. Give me a double thumbs up so that I can move forward. Give me a double thumbs up. Quick. What is the next kind of chemical reaction that we have to study? And which is the most important one, okay? Combination reaction. So pay attention, and I'm again and again telling you this because we have a lot of chemical reactions. So you have to understand everything, okay? The next one is combination reaction. Combination. The name itself says everything. Exothermic reaction, the energy is exiting. Endothermic reaction, heat is entering. So name itself says everything. So here we have combination reaction. What is combination? Combine together. The reactants are combined together. The combination reaction. Combine together to give one single product is called as the combination reaction. So remember what is combination reaction? Combination reaction in which two or more reactants combine to form a single product is called as the combination reaction. So this is combination reaction. So they will give equation something like that, and they will ask which kind of reaction is this. So if you see two reactants and only one product over there, you have to tell like it is a combination reaction. Two or more reactants but only one product. Keep this in mind. Okay, more reactants, two or more reactants but only one product. Okay, only one product will be there in that chemical reaction, but we will be having two or more reactants. So two or more reactants combine together to give a single product is called as combination reaction. Imagine I have two reactants like this. They combine together to give a single product. I can call that as a combination reaction. So remember what is a combination reaction? Unmute one, ma'am. Ma'am, unmute.
Leora.
Leora. In a combination reaction, how many products we will get? Yeah, a single product. Only one product will be formed during this chemical reaction, combination reaction. For example, we have the color over here. We have so much color in the world, right? We have so many of them. So here, the red and blue. We have the color red and blue. When they mix together or combine together, we will get the color violet. Okay, don't write it down. It's a general thing. Okay, so I'm giving the examples. No worries, don't write it down. So red is a color, blue is another color. When they combine together, they will get a single color, violet. Okay, we will get the violet color. And another one, yellow. Yellow and blue together will give green color. And again, yellow, red and blue combined together will get the black color. So what is this? This is a combination reaction. So the colors combine together to give a single color. They will combine and they will give a single color. So what is combination reaction? two or more reactants combined together to give a single product is called as combination reaction. Combination reaction. Okay. So 2 Mg plus O2 gives 2 MgO. Definitely it's a combination reaction. Yes. David, you're back with the notebook, right, David?
Yes, ma'am.
Yes, sir. Very good. Keep writing everything, okay? Yes, very good. So here we go. Ma'am, could you go back to the slide, previous slide for a second? Yes. Here we go. So the colors, we have so many of them and they combine together to give one single color. Again, a combination one. Okay, that is called as a combination reaction. Ma'am, thank you for giving this color combination example. Okay, welcome.
It's Sridhya.
Sridhya. Okay, so we have one more example. Okay, wait for it. Done with the slide? Done with the slide? Regin? Yes, right? Very good. So here we go. The colors, they combine together to give the single color. You have to remember this. Then you will get what is a combination reaction. You will get an idea about that. So here we go with another one. So here we have the hybrid fruits, right? So, sir, can you remove this for a second? We have the hybrid fruits over here. So the two fruits combine together to give one fruit. Again, an example for the combination reaction. So pomelo and mandarin will give sweet orange. They combine together. Two things combine together to give one single product. So it is an example for what? Combination reaction. So in the exams, they will ask like, give the example for combination reaction. So what will you give? You have to write it like bitter orange plus citron will give lemon. So they will give you 0 marks, okay? So don't ever write these examples, okay? I am giving this example for your understanding, okay? Don't give this example in your examination. Don't ever do that. I'll give more example regarding that, okay? So I'm giving these examples for your understanding. Just keep that in mind. Don't do this, okay? Ma'am, what is that comment? Are there?
This one.
General knowledge about the fruit.
I can share it.
Share it with your friends. Definitely you can share everything with your friends so they will get an idea about that, right? So you can do that. Very good, very good. Good attitude. Keep doing that. So here we go. Two things combine together to give an entirely different product. So bitter orange will be having different state, citron will be having different taste, and lemon. They combine together to give the lemon. So they will be having a different property. So in the combination reaction, we will be having two or more reactants, but we will be having only one product. What should we write as an example? That is exactly what I am going to explain now. So listen carefully. Here we go with the examples. This is an important example for the combination reaction. Don't ever skip this. Okay, this is the most important part from the chapter. Don't ever skip this. Okay, so here we go. What is CaO? CaO. What is CaO? Can anyone tell me what is CaO? We have so many hand rises over there. I'm so happy. Very good. Ma'am, unmute one.
Sure, Aris.
Aris. Yes, Aris. What is CaO?
Ma'am, calcium oxide.
Calcium oxide. Very
Answer
good.
it out.
Calcium oxide. What is H2O?
Hydrogen.
Calcium oxide and water. Right? And what is CaOH twice? What is CaOH twice?
Calcium hydroxide.
Definitely. Very good. Calcium hydroxide. So here is an example for combination reaction. Unmute one, ma'am.
Sure, Muhammad Nurul.
Mohammed Nurul. Mohammed. What was combination reaction?
Ma'am, when two or more, when two combine to get product.
Two or more reactant combine together to give how many products?
Yeah. One product.
One product, a single product. So look at these chemical reaction where calcium oxide reacts with the water to give a single product, calcium hydroxide. Here we have, what kind of bracket is that? Wait for a second. Okay, here we go. Here we have two reactants, but here we have only one product. That exactly called as the combination reaction. Two or more reactants combine together to give a single product is called as the combination reaction, along with the liberation of heat energy. So I can call these chemical reaction as what? Is this only a combination reaction? Is this only a combination reaction? Unmute one man.
Ansh.
Ansh.
Yes.
Yes, Ansh. Is this only a combination reaction?
No, it's also a endothermic reaction.
What kind of reaction?
It's also an endothermic reaction.
Endothermic reaction. Are you sure?
No, it's sorry, exothermic.
What is exothermic reaction?
Can I give an example?
No, don't give the example. Give me the definition. What is endothermic reaction or exothermic reaction?
So like a reaction in which accomplishment of evolution of heat.
Evolution of heat is what? Evolution of heat is exothermic or endothermic?
Exothermic.
Evolution of heat is exothermic. So heat is there in the product side. That means the evolution of heat is taking place, right?
Yes,
So it is an exothermic reaction. Am I right?
yes, ma'am.
So for an endothermic reaction, where will you put the heat?
We can either put it above the arrow or
Or along with the reactants. Very good.
reactants.
Reactants or above the arrow mark. So here the heat energy is there in the product side. So it is again called as exothermic reaction. Exothermic reaction. So either it's a combination reaction or exothermic reaction. Okay. So not or and. Okay. It's a combination reaction and exothermic reaction. It's an example for both of them. So here we go detailing with the equation. Okay. For the chemical reaction. Calcium oxide. Ma'am?
Ma'am, actually Mugdha Sunil is telling in order to summarize what you finished till now. And actually she can actually watch it live on YouTube.
Yeah,
Okay.
she can.
Yeah, so Mugdha,
So,
you can
Mukta, there is a YouTube live going on there. So, right after finishing the class, you can just go there and watch the entire class, okay? So, if I repeat everything from the beginning, really the time will be gone. So, I don't have to waste my time on that. So, I have portions to cover. So, you can watch the YouTube live, or if you want the recorded class, you can just ask for the admin. They will provide you with that, okay? No worries. Okay, Mugda, is that fine for you?
Yeah.
Yes. So here we go. The calcium oxide. I can call this calcium oxide as another name. Okay. This calcium oxide have another name called as quicklime. So calcium oxide or CaO. CaO is calcium oxide. Ca is calcium and O oxide. Calcium oxide have another name called quicklime. So quicklime on reacting with the water. If we mix calcium oxide with the water, they will produce calcium hydroxide. And this calcium hydroxide also have another name. Calcium hydroxide also have another name called as slaked lime. Slaked lime. So CaOH twice. calcium hydroxide. CaOH twice is calcium hydroxide, and another name for calcium hydroxide is called as the slaked lime. So what is quicklime? It is calcium oxide. So what is slaked lime? It is calcium hydroxide. So in the rest of the chapters too, we will be having these two things. Okay, so don't ever forget the common names and also the real names for those chemicals. Okay, so CaO, calcium oxide, quicklime. CaOH twice, calcium hydroxide, slaked lime. Okay, slaked lime. So they liberate a large amount of heat energy during the chemical reaction. Let's watch an animation. Okay, let's watch an animation. Let's watch an animation for that. Yes, here we go. Everyone ready for that? Give me thumbs up, give me thumbs up. Yes, very good. So here we have the powder, which is nothing but what? It is called as calcium what? What are we doing over here? It is calcium hydroxide. Suppose then. The powder, is it a calcium oxide or calcium hydroxide? Ma'am, unmute one.
Sania.
Sania. Sania, what was the chemical reaction? Sania?
It was, yes, ma'am, it was with slaked slime.
It was?
With slaked slime.
Slaked lime.
Slaked
Slaked
lime.
lime.
This was slaked lime. The powder.
Yeah.
So what we mixed with water to give what? The chemical reaction was not like that, right? The slaked lime was a product. Now I'm asking about the reactants. What reacted to give you the slaked lime?
CaO twice.
Ca?
OH twice.
CaOH twice is what?
Calcium hydroxide, yeah.
So CaOH twice is calcium hydroxide and slaked lime. So what reacted to give you calcium hydroxide?
Calcium oxide.
Calcium oxide and water reacted to give calcium hydroxide, right? Yes. So here we go with the animation. Yes, sir. Yes, so the powder is nothing but calcium oxide, the calcium oxide. So let's take this calcium oxide inside this beaker, and that beaker will be having water, okay? Let's take calcium oxide in that beaker, calcium oxide. And what do we have to do? We have to add water because calcium oxide reacts with the calcium oxide is also called as quicklime. Yes, the calcium oxide reacts with the water to give calcium hydroxide, and it's a vigorous reaction, okay, with the liberation of heat energy. With the liberation of heat energy, you can see over here, right? With the liberation of heat energy, the calcium hydroxide is forming. The calcium hydroxide is forming. So whenever we mix calcium oxide with the water, we will get calcium hydroxide, which is a single product with the along with the liberation of heat energy. It's an example for combination reaction, and also and also for an example for exothermic reaction. So what is the reaction? Calcium oxide. So don't forget it, okay? Don't forget it. Please keep this in mind. Calcium oxide is also called as quicklime. Reacts with the water to form calcium hydroxide with the liberation of heat energy. Calcium oxide is CaO, which is also called as quicklime. CaOH twice is called as the slaked lime, which is also called as calcium hydroxide. So whenever we mix calcium oxide with the water, we will get calcium hydroxide with the liberation of heat energy. Is this much clear for everyone?
Ma'am, Sumaya wants to see that animation again.
See the animation again. Definitely we'll show that. So was the reaction clear for everyone? Yes. So here we go with the animation again. Then we have the white powder, calcium oxide, and let's put the calcium oxide in a beaker and let's pour water in it because calcium oxide It's a quicklime. Calcium oxide reacts with the water to form calcium hydroxide, and with the liberation of heat energy. With the liberation of heat energy, it's a vigorous reaction. It's a vigorous reaction. Example for combination reaction and exothermic reaction. Heat energy is liberated during the chemical reaction. So whenever calcium oxide reacts with the water, calcium hydroxide will be formed along with the liberation of heat. Okay. Yes, very good. So the calcium hydroxide, we had a product over here, calcium hydroxide, right? The calcium hydroxide or slaked lime. Okay, calcium hydroxide or slaked lime. Now, this slaked lime or calcium hydroxide can be used in whitewashing. Can be used in whitewashing. So what are we used in whitewashing? Calcium hydroxide. Ma'am, unmute one.
Sure. Roshni.
Roshni. Roshni.
Yes, ma'am.
What was calcium hydroxide?
CaOH2.
Calcium hydroxide. What was the chemical name for calcium hydroxide?
Ma'am, CaOH2.
CaOH twice. CaOH twice was calcium hydroxide. What is the common name for calcium hydroxide?
Ma'am, slaked lime.
It is slaked lime. Very good. It is slaked lime. So remember, in exam, they will ask like, which is the substance which is used in whitewashing. So you have to clear that it is calcium hydroxide or slaked lime or CaOH twice, or you can write 3 of them. Okay, so calcium hydroxide, CaOH twice or slaked lime is used in whitewashing the walls. Okay, which one will be used in the whitewashing of the walls? Calcium hydroxide. Calcium hydroxide will be used in the whitewashing of walls. Okay, whitewashing of walls. Now what happens is, we already put a layer of calcium hydroxide on the wall, right? On the wall we already put a layer of calcium hydroxide. Now what they will do? Listen carefully. Listen, everyone listen to me. So this calcium hydroxide on the wall will react with the carbon dioxide that is present in the air. What they will do? Calcium hydroxide on the wall will react with the carbon dioxide that is present in the air. That is present in the air, they will combine together. Calcium hydroxide reacts with the carbon dioxide that is present in the air to produce calcium carbonate. The beautiful calcium carbonate. I will show you the example for that. The equation. Okay. So here we had an equation. CaO is nothing but what? CaO was calcium oxide reacted with the water to get calcium hydroxide. We got the calcium hydroxide. Now we put that calcium hydroxide on the walls, and that calcium hydroxide was reacting with the carbon dioxide that is present on the air. So CaOH twice is what? It is calcium hydroxide reacted with the what is this? Carbon dioxide. Okay, the calcium hydroxide reacted with the carbon dioxide that is present in the air to give calcium carbonate, CaCO3. CaCO3 is what? Calcium carbonate. So what is calcium carbonate? It is CaCO3. So the calcium hydroxide that is present on the wall will react with the carbon dioxide that is present in the air to produce a layer of calcium carbonate along with the water. Water is a liquid. So water, or we can write it as a gas because it evaporates. Okay, so here we go. Calcium carbonate is produced, And this calcium carbonate is the one which is giving a shiny appearance to the wall. You can see the shiny appearance on the wall, right? It is due to the calcium carbonate which is present over there. So calcium hydroxide reacts with the carbon dioxide that is present on the air to produce calcium carbonate, which gives a shining layer, on the wall. Okay, don't ever forget this. Okay, ma'am, this is also an example for the oxidation reduction. Yes, very good. We haven't talked about what is oxidation reduction. We'll talk about that. Okay. Yes. So calcium carbonate. So they will give calcium carbonate which will be having a shiny surface. So after we put the calcium hydroxide on the wall to produce calcium carbonate, it will take 2 to 3 days. Okay. Ma'am, H2O is a liquid. So H2O can be a solid, can be a liquid, and can be a gas because we have ice, water, and water vapor, right? Ice is a solid, water is a liquid, and water vapor is a gas. And the water here formed will be vaporizing, so I given the gas over there. Okay, was that clear?
Ashwin. Okay.
Ashwin? Yes. So here we go. The calcium carbonate is formed which will give a shiny appearance or the shiny coat on the wall, and the shiny coat will appear only after 2 to 3 days. They want to react, right? So it's a slow process. It will take 2 to 3 days. So I can call this calcium carbonate as the limestone. Okay, the another name for calcium carbonate is a limestone. So don't ever get confused with the calcium oxide, calcium hydroxide, and the calcium carbonate. We have 3 things. Okay, I'll write it down here. We have 3 things: CaO, which is nothing but calcium oxide. We have calcium oxide, and which is called as the quicklime. And we have CaOH twice, which is nothing but calcium hydroxide. I can call them as what? Quicklime and slaked lime. And we have one more, slaked lime. And we have one more CaCO3, the calcium carbonate. Or limestone. Okay, we have 3 things. Don't ever forget this. This is the first one, the second one, and the third one. You may have a high chance of confusion. Okay, so don't get confused with these 3. Okay, study that right now. Calcium oxide is calcium. Calcium oxide is CaO. Quicklime, CaOH twice, calcium hydroxide, slaked lime, CaCO3, calcium carbonate, limestone. So you have to study that right now. I'll ask questions. Study that right now. No confusions. No other confusions. And this is an important topic from the chapter, and there is a question, definitely a question in the examination regarding these topics. So please study this. Quick. I'll give 2 minutes. After studying this, I will move forward with the examination. I'll move forward with this examination if you study this. Quickly study this. The first equation, the second equation, and these 3. Yes, ma'am?
Sridhar is having a doubt whether this will be coming under the endothermic reaction.
Which one? The second one? No, it's not an endothermic reaction, but there is no heat energy.
In the case of limestone? No. Okay.
No. What was slaked lime? Calcium hydroxide is slaked lime. So I'll give you 2 minutes to study. CaO is calcium oxide.
She wants to
water.
know the reason also. Why is it not called as an endothermic reaction?
Well, there is no heat is absorbed over here, right? Can you see any heat over there? No. No heat energy is absorbed over there, so no. So on the wall, they just react with the carbon dioxide to form calcium carbonate. So Ma'am, second equation is also a combination reaction. Unmute him. Who's that?
Joel.
Joel.
Joel, can you please hand raise?
Joel, can you please raise your hand? Raise your hand, Joel, if you're there. Joel, I saw your comment.
Yeah.
Raise your hand. Joel,
Yeah, ma'am.
what was the combination reaction?
Ma'am, when it forms one singular product.
One single product. So how
Ma'am,
many?
Yeah.
In the
No,
second
ma'am, it's not
example.
one singular product.
In the second example,
No,
how
no,
many
no,
products
no.
can you see?
Ma'am, two.
Two products are there. How come it's a combination reaction now?
No, ma'am, because H2 is a gas, so when it forms a...
No.
Okay.
Water,
Okay.
even though it is a gas, it is a product, right? If you
Yeah.
got a chlorine gas, so can you consider this as a product? Since it's a gas, it's not a
Yeah.
product, ma'am. So definitely the Cl2 is a gas and it's a product, right? You cannot neglect anyone. So it's a product.
Okay.
So CaCO3,
Okay, ma'am.
even though it's a gas, it's a product. So definitely it's not a combination reaction. The first one is a combination reaction, but the second one is not a combination reaction. Don't get confused with that. Are we going to discuss the last class homeworks? No, not exactly. We don't have time. I hope everyone is done with the homework. Am I right? Yeah, I know. My good children will do that.
Ma'am, Regin is having a doubt whether only this naked lime is used for whitewashing or everything in the second equation is used for whitewashing.
No, not everything. Only calcium hydroxide will be used for whitewashing, okay? For whitewashing, we only use the calcium hydroxide. So the calcium hydroxide is reacting with the carbon dioxide which is already present in the air. Okay, we are not providing any carbon dioxide externally, which is there in the air itself. So they are reacting with the carbon dioxide that is present in the air. Okay, we are not providing the carbon dioxide to that. So for whitewashing, we are only using calcium hydroxide. So if they ask to write the chemical equation, you have to write it like this. Okay? Yes. Because there is more than one product. Here there is more than one product, so it's not a combination reaction. It's not a combination reaction. The second reaction is not a combination reaction, okay? It's not a combination reaction. I have told the application of this calcium hydroxide. Okay, it's the application of the calcium hydroxide. Yes. And the application of calcium hydroxide is not an example for the combination reaction. I am repeatedly telling the second one is not an example for the combination reaction. Okay, it's an application of the calcium hydroxide. Yes. So it's not a part of first one. It's not a part of first one. It's just the application of calcium hydroxide. They doesn't have any relation. Okay, the first one, second half doesn't have any relation. It's just the application. Yes, studied? Give me a thumbs up if you have studied everything in this slide. Ma'am, in the second one is hard, ma'am. Second one is hard. Please.
Second homework is...
Oh, second homework. Okay, fine. We'll discuss that in the next class. Okay, I will discuss that in the next class. No worries. I'll discuss that. Now we don't have time. We have only left with the 7 minutes. We have to do the exam, right?
Is the
No worries.
limestone formed from calcium hydroxide and carbon dioxide?
Yes, calcium carbonate or the limestone is produced from calcium hydroxide and carbon dioxide, definitely. Studied everything? I have given time to study, okay? Someone is like looking around everything. So don't do that. Study. I have given time to study. Study that right now. All the things that is in the slide. Done? So since everyone is done with that, we'll go for the exam. Okay? Shall we start? Shall we start the exam? Done? Yes, give me thumbs up, everyone. Yes, you're all ready for that. Very good. Now the exam is activated. You can just attend there, okay? Double yes, ma'am. Okay. Yes, quickly attend the exam. Here we go. And the next chemical reaction, wait for a second, okay? Wait for a second. I will give you a few more examples, okay? Wait for a second. No. I'll give that in the next session. You have already attended the exam, right? You are doing the exam. Are you doing the exam or listening to me? They are doing the exam, I guess, right? Here we have some more example for the combination reaction. I forget to give you. So at the end of the session, I will give that. Now let's do the exam. So the first question in the exam, okay? First question in the exam was, which of the following is not an example for exothermic reaction? Yes, ma'am?
Manish, he didn't get the exam.
He didn't get the exam. Just go back from the tab and you will get a blue button over there. So you have to just press it over there and you can attend it.
It's not a Google Form exam. Okay.
It's not a Google form. Okay, Manish?
My app is not working, so yeah.
App is not working. Okay. So this is the first question, okay? Someone got 8 out of 10.
10 on 10.
10 on 10. So this is the first question. And the second one. State true or false. Photosynthesis is an endothermic process. True or false. And the chemical formula for calcium oxide. And calcium oxide is also called as what? And which among the following is used for whitewashing of walls? So these are the 5 easy and simplest questions. 10 on 10. Very good. If you are done with the exam, give me a thumbs up. Give me a thumbs up. Let me know if you are done with the exam. Let's discuss it. And I will give you 2 more examples for the combination reaction and we are done with the session. Okay. Give me a thumbs up if you are done with that. Thumbs ups. Done. Shall we discuss it? Or are you guys waiting like, let ma'am discuss everything and I will do the exam so that I can score the full marks. Is anyone waiting for that? No, right?
Haripriya, once you have actually logged into the to the site, you can actually see the link of the exam there. Okay.
Yes. Done. Everyone done with that, right? And for your kind knowledge, your scores are recorded over there. So at the end of the year, all these marks will be calculated. So do the exam carefully. All the marks will be calculated. Okay. Shall we discuss it? Hope everyone is done with that. So here we go with the first question.
Still doing that.
Ma'am, please give me a minute. Definitely. Alright, I'll give the time. Yes. This exam does not show my mistakes. I'm able to improve. Okay. So done? They're like, the ma'am is so impatient. How can be she like that? So I'm waiting over here, okay, for your response. I'm waiting. Yes. Is there anyone who is doing the exam? Not done with the exam? You can just raise your hand. Raise your hand if you're not done with the exam. No one. Everyone done. So let's discuss the questions and you're going to tell me the answer, okay? You're going to tell me the answer. Here we go, the first one. Which of the following is not an example for the exothermic reaction? Not an example for the exothermic reaction. Everyone is showing me the second option. Is that correct? Is that correct? Definitely. Burning of candle produces heat energy. Nuclear fusion produces heat energy. Burning of magnesium ribbon again produces heat energy. So the one which is not producing heat energy is nothing but dissolving salt in water. If you put salt and mix in water, no heat energy is evolved. So it's an example for not an endothermic, not an exothermic, not an endothermic reaction. Okay, so the answer is B. Very good. So here we go, the next one. Photosynthesis is an endothermic process. Is that right or wrong? Give me the answers. Yes, very good. It is true because they are absorbing the light energy from the sun. They are absorbing the energy. Definitely, it is an endothermic process. Very good. So the chemical formula for calcium oxide. What is the chemical formula for calcium oxide? CaO2, right? Someone is like, yes, ma'am. Definitely, you are very much correct. But it was wrong. It is CaO. Very good, children. Have shown me the first one, CaO. CaO2 is the wrong one. Okay, what is CaO2 twice? It is calcium hydroxide. What is CaCO3? It is calcium carbonate. Okay, what is CaO2? Calcium dioxide. Okay, now CaO is calcium oxide. Now moving forward. Calcium oxide is also called as mint lime, ma'am. Mint lime, right? Mint lime is my favorite, ma'am, so I'll go with the mint lime. Have anyone chosen the mint lime option? No, it is what? It is quick lime. It is the first option is the correct one. It is quick lime, not the mint lime. So the last one. Which among the following is used for whitewashing walls? For whitewashing walls, what do we use? We always use calcium hydroxide. What is the other name given for calcium hydroxide? Unmute one, ma'am. What is the other name given for calcium hydroxide?
Ma'am, I can see many hand raisers, so it's very
Okay.
tough, but I'll go with Manish.
Manish. Yes, Manish. What is calcium hydroxide? It is?
Flat line.
It is like a lime. Calcium hydroxide is like a lime. Very good. So students, don't leave. I'll give two more example for the where is it? Here. Two more example for the combination reaction. Okay, burning of coal. Burning of coal. Coal is nothing but a carbon product, right? Coal. Carbon will be there, so we'll represent coal by giving the carbon. Okay, carbon. So quickly take it down. Quickly take it down. So right after finishing this slide, I will leave you guys, definitely. So carbon, coal can be represented as carbon. It's a product of carbon, okay. So reacts with the oxygen that is present in the air to produce carbon dioxide. To produce carbon dioxide. Is only carbon dioxide will be produced? No. Heat energy will also be produced over there. So it is an example for combination reaction and also for an exothermic process. Exothermic process and also it is a combination reaction. And the reaction between hydrogen gas and oxygen gas to produce water. How water is produced? 2H2 plus O2 gives 2H2O. We already know that, right? We know that by Hartley. So 2H2 plus O2 gives 2H2O is an example for combination reaction. But two reactants combine together to give a single product is called as combination reaction. In both the examples, two reactants combine together to give a single product. So both of them are an example for combination reaction. Combination reaction. Understood? Understood this? I'll ask that in the next session. Okay, what is a combination reaction? What is endothermic and exothermic reaction? We already studied 3. And in the next session, we are going to study the decomposition reaction. Okay, we'll study decomposition reaction. And we have 3 types of decomposition reactions. We'll study that. Done with this? Have you took down everything? Yes. So these are the examples for combination reaction. What is combination? 2 reactants, 1 single product. 2 reactants, 1 single product. Don't ever forget it. Don't ever forget it. So it's time to end the session. Time to end the session. Okay. Thank you so much, and thank you so much for listening to me, for studying everything, for taking down everything. Thank you so much. And I'll meet you in the next session. Until then, take care and bye bye. Good night.